Imagine entering a world that defies everything you know about how things work. Welcome to quantum physics, the science of the super small and the incredibly mysterious. Today, we're taking a short yet informative journey into this fascinating field to uncover what it is and how it fundamentally alters our understanding of the universe. I will always give you important information and explain it with an easy-to-understand example afterwards. So let's get into it. Chapter 1. Quantum Basics. Quantum physics is the branch of physics that deals with the tiniest particles in the universe, electrons, photons, and beyond. Unlike classical physics, which describes how things behave on a scale we can see and touch, quantum physics operates on the level of the very small, where the rules as we know them don't apply. Now here is an example. Consider light. It can be both a wave, spreading out and bending around corners, and a particle, hitting your eye in distinct packets of energy called photons. This dual nature is central to quantum mechanics, illustrating how our classical intuitions about the world are challenged at the quantum level. Chapter 2. The Principle of Superposition. One of the most mind-bending principles in quantum physics is superposition. It states that quantum particles can exist in multiple states or places simultaneously until they're observed. Here is an example. Imagine you're in a room with two doors. In our everyday world, you can only exit through one at a time. But in the quantum world, you could exit through both simultaneously, a phenomenon that's as bizarre as it is real in quantum mechanics. Chapter 3. Entanglement. Another cornerstone of quantum physics is entanglement, a phenomenon where particles become connected no matter the distance separating them. Change the state of one, and the other changes instantaneously, a property Einstein famously referred to as spooky action at a distance. Here is an example. Think of having two coins that always land on the same side, even if you flip them miles apart. This entanglement is not only fascinating, but also the basis for emerging technologies like quantum computing and secure quantum encryption. Chapter 4. Quantum Computing. While traditional computers use bits as the smallest unit of information, which can be either 0 or 1, quantum computers use qubits. These can be 0, 1, or both at the same time thanks to superposition. This allows quantum computers to process information in ways that are fundamentally different and potentially far more powerful than traditional computers. Example. If solving a complex problem is like finding a way out of a maze, a traditional computer tries one path at a time, while a quantum computer can explore all paths simultaneously. Chapter 5. Quantum Uncertainty and Measurement. The Heisenberg uncertainty principle tells us that there's a limit to how precisely we can know both the position and the velocity of a particle. This inherent uncertainty at the quantum level introduces a fundamental randomness in quantum physics, challenging our ideas of determinism. Here is an example. It's like trying to take a perfect photo of a running child in low light. The faster they move, the harder it is to get a clear shot of their position at any given moment. The conclusion. As we've seen, quantum physics opens up a world where the usual rules don't apply, from particles being in two places at once to instant communication across vast distances. It's not just theoretical. Quantum physics is leading to breakthroughs in computing, medicine, and cryptography, potentially reshaping our world. In just a few minutes, we've only scratched the surface, but one thing is clear: the quantum world is strange, exciting, and full of unanswered questions, pushing the boundaries of what we know about the universe. If you enjoyed today's video, I would really appreciate a like. And if you want to see more videos like this one, make sure to subscribe. See you next time.